Welcome to Termite Machine Works. My name is Keith. Today we have a large hydraulic cylinder off of a wood splitter, and evidently it's leaking. And this was dropped off here. And quick note, you drop off hydraulic cylinders, please empty out the fluids. I'm not a waste disposal company here. Anyhow, back to this. We need to go ahead and rebuild this as far as replacing the seals. And as we get this out, we'll be inspecting the ram and a couple other things that might cause seals to leak, or was it just dirt, oil, old? Were they pinched assembling it or whatever? This looks like a pretty new cylinder, but he does have a leaking problem. So we're going to get ready to take this apart. Now, this has, the nut and caps are always held on differently, internal snap rings inside the bore, and different locking mechanisms, screw-on caps, and you know, several different ways to locate or hold these in place. And this one here happens to have an access hole right here, and then two flats out here. Now we need to have a wrench to go over this so we can rotate this around, and we don't happen to have one with a square D type cutout on it. So we're going to go ahead and we're going to head into the plasma cam, and we're going to go ahead and cut one out of an 1/8 inch piece of steel that's protruding out about 1/8 of an inch, and that's really all we need to get on there. We just need to rotate this thing around, and we should be able to work that locking ring right out of this opening. Now, before we go into there and we cut out that wrench and bring it back in here to use it, we're going to set this up into the lathe. Not that we're going to do any machine work on it. We're going to use the lathe to hold this. And we want to be able to use the gearing and the chuck of the lathe to actually grab a hold of this and hold it in place while we do the wrenching on the end here, or rotate it around where it's comfortable or whatever, but using the lathe as a tool to hold this object. Now this is 4.5 inch on the diameter here, and we went and found a piece of 4.5 inch material, and we put it in a 3 jog. We're going to swing it on over, and we're going to go ahead and set the steady rest, because the chuck's going to hold it here. We're just going to be resting it with the steady rest over in this general area over here, so that it's actually in line and sitting in the lathe well supported. Alright, now we just got this loose and we're going to slide this in. This is almost at our max diameter, and this is another reason why we want to go ahead and make another steady rest, is because we've had to modify this to get to the 4.5 inch diameter here, which we know it will just barely fit in here. Got to have just a little bit of a snug in here because get those to hold off. Alright. In fact, actually, and this is another item that I do like, a feature putting in just a straight pin to hold that the top half on there. You can pull that out if you want. You can put cotter pins on each side. Originally I was thinking something like that, but it stays in there pretty well, and we may incorporate that in our same design. Alright, back to the project at hand. And that's to go ahead and set the steady rest up, and then we'll slide it out here, and then we'll get the cylinder mounted in here. Pipe is not 100% round and true, and it does have a coarse surface to it. What I was looking for is just a general contact and driving up these rollers, the whole cement, the whole run of the diameter itself against there. Alright, now we're going to go ahead and we're going to pop out our piece of material. We're done with that. And we're going to go ahead and slide this down where we we'll measure the cylinder here. And 2 foot off of the butt end here would be kind of cool. Somewhere in there. Now we know we have a weld over here, and now if we wanted to hold this true over here, and we were to do some machine work on here, the fitting's not really in our way of holding this, but that weld is kind of holding it about, you know, not true in line with the OD. A couple ways we'd either, if we just wanted to surpass or have a certain amount of allowable run out, we could take a couple shims and put them in between the jaws so that they were equally spaced. So you got 3 equally spaced 3 jaws that run within about 5 thousandths, and then you got 3 shims or so that put in there, and maybe another thou or 2, or maybe it even corrects it slightly. But that would hold, and you can always put an indicator right here and find out how far you run it. But if you wanted this to run perfectly true on this end, you would want the 4 jaw in here, and you would go ahead and probably put aluminum underneath your jaws so that you have the ease of slipping and adjusting, and go ahead and dial that in true. Alright, but right now all we want to do is create the gear train and use this as a tool of holding it for the rotation. Alright, now we're going to go ahead, and I'm going to get you in here close so you can actually see the little slot that we're going to be working out of. And we're going to go ahead and take dimensions of to make our wrench, and then we're going to go do that. Alright, now on the hydraulic cylinder here, in fact actually the head pressure is back that way there, so we're going to lightly tap this back this direction, slightly this way, maybe, oh I don't know, I think we got about 100 thousandths that's hanging, but right there you can see that, that locking ring. And we'll get it knocked back this way here so that that ring is lining up with this slot right here, and then we got to rotate it, and one of the ends of this ring here will show us, the old timers, they come up with a soft pliable ring, and this setup right here to where they're able to put the ring in there with a little point, and as you roll it around, the ring pulls itself right into this slot and around the groove inside the cylinder. And that's how these are held in. But we got to make the wrench and verify all of our findings. And this is from experience of pulling another one apart in the past. There is no other locking hole or slot. That is the one that we have to deal with. All right. So basically, we just need two dimensions here, and this is like 3,980 or so. So we're just going to call that a 4-inch bore. The wrench will have a bore, a 4-inch. Now we need 2 flats, or the what they call a square D, double D surface, whatever you. There's 3 inches and 60 thousandths, and we could go ahead and just pretend that that would be like 3/100. And I'm sure that our allowable kerf and everything else on the plasma torch is going to get it in there close enough to work. We might even be able to go like 390, 380, but the true width there is 3 inches 60 thousandths. Alright, let's go draw a wrench in and cut it out on the plasma cam. Welcome to my plasma cam Design Edge software, and this is my computer screen. This square here is the plasma table, and these lit up dots in here represent the spikes on the table. Alright, we're going to start drawing our wrench by grabbing a square or rectangle here, and you can see the literature down here that kind of gives a hint of some of the things that I'm drawing and what it asks for. Alright, so we're going to draw the first corner of the triangle or rectangle or square. 0.0. The second is going to be this dimension of it, which is 3 inches .90 by 3 inches, .90, and there's our square. Now I'm going to grab that square, move it up here in the table a little bit, and we're just going to zoom in a little bit on it. Now I'm going to check my settings here. I want snap to no point. So I can grab that node or dot and put it right in the center there. Now I want to put a circle, the 4-inch circle here, in relationship to this square or flat dimension here, so we can create the inside of our wrench. And that was 4 inches, which is placed just like that. Now we want about 1 inch of meat for material on our wrench out here, so I'm going to grab another circle and just type in 6 and enter and place that on there as well. Now we need a handle on this wrench, and I'm going to grab a shape here, and I have an oval in here that I like using from time to time, and it happens to be the size that I'm going to put on that wrench, and it's 1.5 inches wide and 12 inches long. This is a list of things that you have parameters or properties that you can create different arrangements with each of those items, but I'm not going to get into those at this time. We're going to grab this oval here, and we're going to place it like that. Alright, we want to grab another circle, the same width as this handle, which is 1.5 inches. And we'll type that, and we'll set that right in on there. That is just so that we can take and move this. Come in here a little bit closer. And we're going to line it right up with that. Alright, we can grab that circle now, and we can get rid of it. And we can zoom back out. And there's our basic wrench. Now I'm not happy with the square being in line with the handle, so I want to cock it a little bit, so I'm just going to rotate it. And I grab the node there, anywhere out here, and I can rotate it anywhere I want on that rotation there. And I'm just going to type in 30 degrees because it's kind of an oddball, and it lets you flip the wrench over and be in another spot slightly different. So if you want to readjust on the grip that you got, it'll be fine there. Alright, now let's go ahead and clean up what we don't need out of the center here to create the grip for on our nut there itself, or the hydraulic cap. We can grab these scissors here, and we're going to go ahead and we're going to nip these little corners here. And then we're going to go ahead and nip those 2 lines. And we can go ahead and take out that one, that one, that one, that one. That one will highlight and then hit delete. And the same with that one. And the same with that one. Alright, now we can highlight part of that, join that. That's one continuous closed loop. We can hit that one, join that, and something's funny. So what you do is you go ahead and you, well, first off, you got to light it up. Then you can detect the intersections, and there's 2, and they're right there. So we just zoom in on them. There's the problem that didn't quite get deleted. All right, and we can cut one side of that. Well, we can cut both sides of it. Just sometimes I don't get that lucky. Okay. All right. We'll zoom out now. And now that we have that, let's try that now. And we do have a continuous loop. All right. Now, let's just say we want to double check that width there. We have a tape measure up here, and we can grab that. Oh, before we do that, let's shut off snap to no point, because sometimes that makes your tape measure go where you don't really want it to. And I got the tape measure, and I can go anywhere with my tape measure now. So let's zoom out. Let's go over to the other side, zoom back in, and click that. And we
I got 3 inches 92. So we're within 2,000 of what we typed, and we were probably off that far by where we placed our tape measure. Alright, now that's just one way of confirming. I mean, we can measure everything, but I'm pretty convinced that we've got it in the dimension that we want, and that's the size that we want. Now I'm concerned about this sharpness here and here, because we got nice radiuses all over everything else. So let's go ahead and I'm going to put a radius in here, and we're just going to type in 0.5. So we're going to give a 1/2 inch radius, and we're going to click that one, and there. Now we have a nice, no stress rising areas right there. Alright, now I want to go ahead and create cut path, and I can convert the cut path by clicking it, and I'm clicking the outside where I want it to be on the outside, and it's easy to sand this radius right here. Alright, automatically convert holes inside, yes. Alright, so there's your start right there, and they gave me that start on the inside, but I don't really like it starting in on the flat and then coming around. I want to start right in one of those corners. It just, in my experience there, so I can go ahead, I can convert to cut path. Now I can come in and I actually place this where I want, and it can be right there. Alright, I happen to have wide cut paths selected up here in the settings. In my settings here, you have show wide cut paths, okay? You can set that on, or you can turn it off. Alright, but let me show you what's neat about having it on. And when you look at it, and let's go ahead and let's take the tape measure again, and I'm going to click there and across here, and of course I just grabbed 2 spots there. I didn't really zoom in ultra detail there, but there's 82 thousandths. It's basically an 80 thousandths kerf width, and that's pretty standard. It does narrow a little bit when you get finer, and it does grow a little bit when you get coarser on than a 60 amp nozzle or contact tip there. But on the average, I'd say that it's pretty close to an 80 thousandths kerf, and it's pretty close to my experience of having that. Alright, now let's go ahead and zoom out here, and we're going to go ahead and we're going to marry everything that we put there so that we can highlight it, and then you can easily manipulate it anywhere on the table. Alright, and then you can place it, or you can you can manipulate it anywhere on the table, and then you can stop it and put it wherever you want. And so now we're done drawing our wrench, and we need to put it somewhere on the table, and we got to go hunt down a piece of material, and we'll put it on the table, and then let's get it cut. Not much dross on the back at all. Pretty nice handle. Yeah, we'll give a quickie cleanup on it. We'll
on my gloves. All right, we did do a little filing on the inside here, just to basically just to almost just put a file surface on everything. It was tappable right on there at the beginning, and I'm right about there now. I mean, it just barely. All right, so with minimum work, I have a wrench that fits that square diameter. If you're a senior citizen. All right, so we got our wrench to fit on here. Of course, it's not going to swing all the way around, so we're going to pop that off so we can get over here to what we're going to view in here. Now we need to tap that in slightly, and it doesn't take much to bring it in a little bit. It probably actually has a shoulder that sits in on there. All right, now which direction this goes, I have no idea. But let's say that somebody tightens it in normally. So I'm going to say that taking it and bringing it back this way. Alright, here's the end. You know, what it tells me is I should have screwed it the other way. Alright, so they drew it in, pulling this way here. We're going to be taking this ring out, going in that direction there. Okay, I'm going to go ahead and, just because you saw me fight this just a little bit on and off, and I'm going to go ahead and hand file just a little bit more out of this wrench, so that, because I'm going to have to stick a probe down in here and screw this all at the same time, and I don't want to be fighting this on and off each time I do there. But like I said, I just barely hit a file to it, and we are pretty snug. That's not, that's not bad for making a wrench. If you need a wrench, go in there and draw it out, create a wrench. We did forget to put a hole on here so we can hang this on the wall, though, right? Alright, well, I went and I found, I don't know if you have any of these, but this is my one Craftsman screwdriver that is now, it's used for everything else. Chisel, prior outer, whatever comes into handy. You keep hitting it on this end and it never breaks. It's just one of those all-around good beaters, and I went in and dressed out the width so that I could get in here and kind of help pry up this end of the ring there, because it's one part of the ring goes down into a hole, and then the other part just wraps around as you pull it through. And I've got the wrench fit now here so that I can just put this on here. And of course I'm going to have to lift up on here, so we better put the steady rest on. Alright, and that. Alright, so now we can lift up on this, and we don't have to worry about I might need something. That is the trick. You get the bitter. You got to get the bitter end of this ring up out of that hole for it to peel all the way out. And this is a real soft piece of steel in here. It's like a leaded piece of stock. Oh, here we go. We got it. Once you get it started like that, all right. See how that just pushes out of there? It's like a leaded piece of stock is what it is. And
we just continue bringing it around. Okay, oh, there's the end. Okay, now they bend the end of it there. That goes down into a little hole. When I get this out, I'll show you that section there as well. But you start that in, and then you draw it around. Now you leave it right in that same shape right there. Of course, you may go ahead and deburr a little bit, and you can see that it did gall going in at one time, because it has orange paint in there underneath that gall there. So they had sprayed this after it was already galled. Alright, now we can take out the inner cylinder here and get rid of the steady rest here. Alright, I'm going to see if I can get an eye bolt in there to where I'll be able to winch, pull it, and just get a small come along up here, and I can pull that out of there. Alright, well, we were able to screw a 1/2-inch eye bolt in here. At least, you know, we got it in there about a 1/2 inch. We'll grab the tail stick and see if we can pull this out. Oh yeah, okay. And it's not, doesn't feel like it has that much restriction. So these seals may be, they may be just a little bit dry rot. Alright, I'm going to move a couple things here on the end. And I'm going to go ahead, just take that ram, and I'm going to try to just like gently tap that end out of there. I just took out the live center. Don't really need to jab my hand right onto that. Okay, a couple of little slides. Got it to pop free. It was just the O-ring pressure that was going over through the groove. There's that opening of that hole, and there's how that piece gets drawn in right there. Alright, now we're going to finish wiggling this out. And easier said than done, huh? Part of the O-ring there. I'm just going back in a little bit here just to make sure there's nothing else in there. There's a couple other little pieces here of debris in the ring. Oh, and there is a little bit of raised metal on this side of the ring. Like I told you, that ring had galled in there, and I think that material raised up is keeping that one from going. And there's more. That's rubber. That's that white backup ring right here on that seal right there. That doesn't sound real good there, but we'll get this apart here, measure up those seals. I'm going to have to reach in there with my little sanding drum, knock off that little ring there so that this piston can come on out. And we're going to put all new seals and piston rings and everything else on this as well. Well, hopefully you can see that angle there, and I'm going to try to get down in here as low as possible to go ahead and show you. But this side right there, there's a raised area right there from the ring being galled. So we're just going ahead and we're just taking it.
Not trying to take any material off of it, just trying to get rid of that little raised lip. Okay, we just run our finger around, just making sure that it is all clear. Alright, we're going to blow some air in there now. You can notice that we laid down a cover on our ways of our machine. We don't like this kind of grit stuff. Alright. Alright, just want to zoom you out because I'm going to attempt pulling this out again. We did wipe that. I don't know, let's see if it will come out now. That piston ring may actually be catching on there. We may get her on the floor there. Go and put a little air pressure behind the unit and get it to push out. I'm going to try and see if we can get a slide on here. I doubt it. Oh, but there's another. See, it is. It's got debris kind of like stuck in there. I'm looking at the groove here, see. Yeah, it's just that seal right there. Okay, back to the drawing board. Alright, we're going to go ahead and create our own windlass here. We got a short strap, and we got it over a tailstock here. And we're going to go ahead and mount this little shackle on here to this eye bolt. Alright, we're going to go ahead and push that back. We're going to lock the tailstock here. Alright, and we're going to take a screwdriver, we're going to cram it in here, and we're going to have to lock the lathe headstock again. There we go. Alright, now as we twist this, you should give a little bit of pressure, and we do a little bit of jiggle, and pull it out. Yeah, she got some pretty good scoring on there, and there was another piece of white ring. Looked like it come off of the main piston ring. This piston is pretty well scored. This rod has been welded on the end here. I think chances are that somebody, let's say they came from factory there for this is a Yard Man tool. Alright, we got these setting up here now. I see some scoring going on in here, and also this piston right around here is extremely scored. Now, okay, see how cheap Yard Man cylinders are put together. That cylinder head is welded right onto the end, so there is no maintenance on removing that or any other seal in here. And you know, if that trashes out, it's pretty well trashed. I'm gonna have to polish some of those grooves out of there. It doesn't look like it really lost any diameter on there. I drained purple fluid out of here, liquidy purple fluid. I know it didn't have the viscosity of hydraulic oil. It was really, it looked more like transmission oil. Now, I'm not saying that transmission oil can't substitute for hydraulic oil here or there, but when it comes to hydraulics, do not shortcut your fluids. Just like not shortcutting your engine oils and other things like that. Some fluids also affect seals and other things like that different than the appropriate fluids. And, you know, stretching out, wearing out, drying out your O-rings and stuff like that cause things to fail. This cylinder head here, I mean, it has no restriction here, okay? And, you know, I'm looking at the seals in here, and that's a wiper there, and a seal in there, and really doesn't look like it's supporting much, and I could tell that it was rubbing on the metal here. Alright, so we're going to pop that out of there, and this wiper out of here. O-ring, backup ring, and we got one compression ring, and we're going to order those. And while we're waiting for those to show up, we're just going to do a quick clean on the outside. We're going to polish the scoring on the cylinder and the piston there, kind of make sure that this is debris free, and also the keeper ring. We're going to make sure that all those highs and that scoring is all off of there as well, so that this can go back inside with no problem.